Imagine being an American military officer during World War II. The scientist walks into the room and tells you he has discovered a new way to guide a bomb toward an enemy target. No radar, no advanced computer, no radio operator. Instead, he wants to put pigeons inside the bomb and let them fly it. It sounds like a joke, but it wasn't. The United States actually spent thousands of dollars developing this idea during World War II. The pigeons were trained, a guidance system was built. Military officials watched demonstrations, and according to the man who created it, the strangest part was that the pigeons actually worked. This was Project Pigeon, one of the most bizarre guided weapon experiments of World War II. And it began because America had a serious problem. In the early years of the war, hitting a small target from the air was much harder than it looked. Today, precision-guided weapons can use GPS, lasers, radar, cameras, and powerful computers. But during World War II, those technologies were either primitive, experimental, or completely unavailable. A bomber could fly directly over a target, release dozens of bombs, and still miss. Weather could obscure the ground, wind could push bombs away from their predicted path. Anti-aircraft fire forced pilots to maneuver. Smoke could hide important targets, and attacking a moving ship was even harder. A ship could change direction after a bomb had already been released. Military engineers desperately wanted weapons that could correct their own course after launch. Germany was developing guided bombs. The Allies were experimenting with radar, radio control, television guidance, and other technologies. But electronic systems of the early 1940s were large, expensive, fragile, and complicated. Then an American psychologist named Burrhus Frederick Skinner looked at the problem from a completely different direction. Skinner was not an aircraft designer. He was not a missile engineer. And he was not a military officer. He was a psychologist. His specialty was behavior. Skinner was studying how animals learned through rewards. His experiments showed that animals could be trained to repeat very specific actions when those actions produced food. One of his favorite experimental animals was the pigeon, and Skinner became fascinated by how quickly pigeons could learn. To most people, a pigeon was simply a city bird. To Skinner, it was something else. It had excellent vision. It reacted quickly. It could recognize visual patterns, and with the correct training, it could perform the same behavior again and again. Then one day, Skinner watched birds maneuvering through the air. They could turn rapidly, they could maintain direction, they could react to changing visual information, and an idea appeared. What if the brain required to guide a weapon already existed? What if instead of trying to build an electronic machine capable of recognizing a target, you trained an animal to recognize it? Skinner began experimenting. The basic principle was surprisingly simple. A pigeon would be shown an image. The image might represent a ship, a building, or another military target. Whenever the pigeon pecked directly at the target, it received food again and again and again. Eventually, the bird learned a basic rule. See the target, peck the target. Skinner could then move the image. The pigeon followed it. Move. The target left. The pigeon pecked left. Move it right. The pigeon followed right. This meant that the bird was doing something extremely important. It was tracking a moving visual object. Now imagine placing that pigeon inside the front of a guided bomb. In front of the pigeon was a small screen. A lens in the nose of the weapon projected the view ahead onto that screen. If the weapon was flying directly toward the target appeared near the center. The pigeon had been trained to peck the target, so it pecked the center. But if the weapon drifted left, the target image moved across the screen. The pigeon followed it and began pecking away from the center. That movement could be detected by the guidance mechanism. The controls would then correct the direction of the weapon. As the bomb turned back toward the target, the image returned toward the center. The pigeon followed it. In other words, the bird became part of a biological guidance computer. The animal did not understand that it was controlling a weapon. It did not understand aerodynamics. It did not understand war. It simply performed the behavior it had been trained to perform. Follow the target, peck the target, and get the reward. Skinner believed this could solve one of the hardest problems in guided weapon development: target recognition. A machine in the 1940s had enormous difficulty looking at a complex landscape and deciding which object was the enemy ship. A trained pigeon could simply recognize the visual pattern it had learned. But trusting one pigeon with a weapon was risky. What if the bird became distracted? What if it stopped pecking? What if it made a mistake? Skinner's answer was even stranger. Use 3 pigeons. The proposed guidance compartment could contain 3 separate birds. Each pigeon saw an image of the target. If the birds agreed on the direction, the weapon followed their combined response. The idea created a primitive, form of biological redundancy. One pigeon might make a mistake. 3 trained pigeons were less likely to make the same mistake simultaneously. And then Skinner began testing something even more important. Could the pigeons continue working under conditions resembling combat? A missile or glide bomb would not be a quiet laboratory. There would be vibration, noise, acceleration, changes in pressure, changes in temperature, and violent movement. If the pigeons panicked, the entire system was useless, so Skinner exposed them to increasingly stressful conditions. Loud noises, bright lights, movement, pressure changes, temperature changes, acceleration. The birds kept working, they continued pecking. Skinner became convinced that the pigeons were far more reliable than military officials expected, and eventually, the idea attracted serious attention. General Mills, the American company better known for food products, provided technical assistance. Yes, a cereal company helped develop a pigeon-guided weapon. During wartime, however, American industry was being redirected into all kinds of military research and manufacturing. Engineers who normally worked on civilian products could suddenly find themselves developing military equipment. In 1943, the project received a government contract worth approximately $25,000. That was serious money at the time. The strange experiment now had official support. The program became associated with the development of a guided glide weapon, sometimes called Pelican. Skinner's pigeon system was intended to provide the guidance. Inside the nose would sit the animals, ahead of them optical lenses, behind them the explosive weapon. The concept sounds absurd today, but remember what engineers were working with in 1943. Modern digital cameras did not exist. Microprocessors did not exist. GPS did not exist. Compact artificial intelligence obviously did not exist. Even sophisticated electronic guidance technology was still developing rapidly. Skinner had essentially found an organic substitute. The pigeon's eyes became the camera. Its brain became the image recognition system. Its trained behavior became the tracking software. Its beak became the control input. And the mechanical system translated those pecks into steering corrections. From that perspective, Project Pigeon suddenly sounds much less ridiculous. It was an attempt to solve a technological problem using biology. Then came the demonstration. Skinner placed a trained pigeon in the guidance apparatus. Officials watched. An image representing the target moved across the screen. The pigeon immediately followed it. It pecked steadily. When the target moved, the bird moved with it. The system responded. Skinner had demonstrated exactly what he had promised. The pigeon could track the target, and according to accounts of the project, the birds could remain extremely focused. Even attempts to distract them often failed. The experiment had reached a strange position. The birds were doing their job, but the humans still did not trust them. For military officials, there was a psychological problem. Imagine explaining to a commander that a highly valuable weapon containing explosives would be guided toward an enemy ship by 3 pigeons. If the weapon missed, the explanation would sound ridiculous. And by 1944, many competing guidance technologies were developing. Radar was improving. Radio control was improving. Electronics were becoming increasingly promising. Scientists and engineers had limited money, people, equipment, and time. Every experimental project competed with another project, and military planners had to decide which technologies had the greatest chance of reaching combat quickly. Project Pigeon was unusual. It was difficult to integrate with the weapon being developed. And despite Skinner's successful behavioral demonstrations, officials remained uncertain about turning it into a practical combat system. On October 8, 1944, Project Pigeon was cancelled. The military wanted resources directed toward technologies with more immediate promise. The pigeons never went into battle. No operational American bomb was flown into an enemy target by Skinner's birds during World War II. And at first, it seemed that one of the strangest military experiments of the war was finished. But there was an interesting twist. Skinner did not immediately forget about the pigeons. He kept some of the trained birds. Later, he tested whether they still remembered what they had learned. Months passed, then years. According to accounts of the experiments, some birds could still perform the target pecking behavior long after their original training. That reinforced Skinner's belief that the concept had been technically underestimated. Then, after World War II, someone in the military became interested again. In 1948, the United States Navy revived the general concept. This time it received a new name. Project Orkan, short for Organic Control. The Cold War had begun. Guided missiles were becoming increasingly important. Ships were valuable targets, and engineers still needed reliable methods of guiding weapons. Once again, pigeons were studied as possible biological guidance systems. The idea had survived the war, Tests continued for several years, but the technological world was changing faster than the pigeons could compete. Electronics became smaller. Radar became more reliable. Guidance systems improved. Engineers learned how to build weapons that could detect and track targets without putting a living animal inside them. By 1953, Project Orkan was cancelled. This time, the pigeon's career as a missile guidance system was effectively over. The future belonged to electronics, but Project Pigeon was not necessarily a failure, because the fundamental idea behind it was remarkably modern. Consider what the pigeon was actually doing. It observed the world, identified a target, detected when the target moved away from the center, produced a correction, observed the new position, then corrected again. That is a feedback loop. Modern guided weapons operate using much more sophisticated versions of the same basic principle. Sensors observe, computers calculate error, control surfaces adjust, sensors observe again. The cycle continues until the weapon reaches the target. Skinner had created a biological version of that process. The difference was that instead of a camera connected to computer software, he used eyes connected to a pigeon's brain. And Project Pigeon reveals something important about wartime innovation. Wars create problems faster than engineers can sometimes invent conventional solutions, so people experiment. World War II produced countless unusual military projects. The United States investigated bats carrying tiny incendiary devices. Britain experimented with bizarre explosive concepts. Germany developed enormous weapons, remote-controlled demolition vehicles, and guided bombs. Scientists were trying almost anything that might provide an advantage. Some ideas became revolutionary, others disappeared, and some existed in the strange space between brilliant and ridiculous. Project Pigeon belonged there. The military laughed at the concept, but Skinner's pigeons repeatedly demonstrated that the underlying behavioral system could work. The problem was not simply whether a pigeon could follow a target. It could. The real problem was whether an entire reliable weapon could be built around that pigeon quickly enough to matter, and eventually technology offered a better answer. That may be why this story is more interesting than simply saying, America tried to put pigeons inside bombs, because the project reveals a moment when biology temporarily competed with electronics. For a short period during World War II, nobody knew which path would ultimately win. Today, a missile can contain cameras, radar seekers, infrared sensors, computers, inertial navigation systems, and satellite guidance. But in 1943, engineers were trying to build the ancestors of those systems. And one psychologist looked at a pigeon and realized nature had already produced something his era struggled to manufacture: a compact visual sensor, a pattern recognition system, a processor capable of responding instantly, all weighing less than a pound, the pigeon's brain. Project Pigeon never reached combat. It was cancelled before its birds could become what Skinner imagined. Then it returned and was cancelled again. But one surviving nose-cone prototype eventually became part of the collection of the Smithsonian's National Museum of American History. A physical reminder that this was not an internet myth, not a comedy sketch, and not a fictional secret weapon. The United States really experimented with pigeons guiding weapons during World War II. The pigeons learnt the targets, they passed demonstrations, they survived the stress tests, and apparently they were ready to keep pecking. The military simply decided the future belonged to something else: electronics. So the next time you see a modern precision weapon following a target automatically, remember that more than 80 years ago, scientists were trying to solve the same problem with something far simpler: 3 pigeons, 3 screens, and a bomb. Perhaps the strangest part of Project Pigeon is not that someone proposed it. The strangest part is that it almost worked.